Hello students, in today's class let us revise the second chapter, relations and functions. So what is meant by a relation? Before getting into relation, we have learnt what is meant by the Cartesian product of sets. When we have two sets, how to find a Cartesian product. For any two empty sets P and Q, Cartesian product is defined as P cross Q, which is set of all ordered pairs in such a way first element is taken from the first set and second element is taken from the second set. So the set of all P comma Q, where P belongs to P and Q belongs to Q, is called the Cartesian product. Alright, if either P or Q is null set, then P cross Q will be empty. If any one of the set is going to be empty set, then automatically cross product is also empty. We will call it as a cross product or Cartesian product. Hope you remember all these things. If we want to find cross product of two sets, whatever set is mentioned in the first, you have to choose the elements from that set first. So which means if you take A cross B and B cross A, A1 B1 is different from B1 A1. It is not the same, right? It is like plotting of the points. When we look up the coordinates of the point, 2, 3 is not same as 3, 2. 2, 3 has its own location, 3, 2 has its own location in the Cartesian plane, right? So the same way these 2 points are different. So it all depends on in which order you are going to find the Cartesian products. When we call two ordered pairs are equal, if and only if the corresponding first and the second elements are equal. What I told right now. If the positions are changing, then these two ordered pairs are not equal. It should be exactly matched. Then only the ordered pairs are called as equal. You can remember the plotting of the point on a graph. Okay. If n of A is P and n of B is Q, then what is n of A cross B? It is going to be P into Q. So how many ordered pairs will be there in the Cartesian product of two sets? P into Q. Okay. Then what will be the Cartesian product of three sets? It's like a triplet. Here we will call it as an ordered pair. There it's going to be an ordered triplet. Here pair, there it is triplet. Right. So A cross B is not equal to B cross A, as I told you now. Our first exercise is fully based on Cartesian product only. Hope you remember and you can do it well. How you will do these kind of problems? A cross B intersection C. First you have to find what is B intersection C using these two sets. Then for that B intersection C, you have to do the Cartesian product. A cross B intersection C. Right? So what will be A cross B intersection C? Just now I told you, if either of the set is empty, the entire cross product is going to be empty. Here cross intersection is empty. So when you do the cross product with the empty set, it is going to be empty only. Now how will you find A cross B? You know, A you have, B you have. So 1, 1, 1, 2, 1, 3, 1, 4. Then 2, 1, 2, 2, 2, 3, 2, 4. Likewise you have to do. Then A cross C. Then you have to find the intersection. Intersection means common elements. How will you find the same elements? They should match in the order. First element should be same as the first element here, and second element should be same. In the same order, if they appear only, they are equal ordered pairs, or else they are not. Okay. So hope you remember all these things. Cartesian products. Our first exercise is completely based on Cartesian products. Then we have learnt what is meant by a relation. What is meant by a relation? A relation from a non-empty set to another non-empty set is the subset of a Cartesian product. A relation is a subset of a Cartesian product. So a relation between the first and the second element of the ordered pair in A cross B. So we will have a set of Cartesian products. We will have a set of ordered pairs, and we will define some relation between those elements. Okay, some relationship we will define. That is called a relation between the first set and the second set. Right? For example, see, the set A has A, B, C, and set B has a B, Banu, Binay, Chandra and Durai. Now here the relation defined is x comma y. So it is clear, since it is a subset of A cross B, in the relation also we are going to have only ordered pairs. So x is the first letter of the name y. So x is the first letter of the name y. So if we find the ordered pairs, What are all the things we will have? A comma Abhi, A comma Banu, A comma Binay, A comma Chandra, A comma Durai. Then B comma Abhi, B comma Banu. Likewise, we will have all the ordered pairs. Okay, so that is the Cartesian product of A and B. We will be having 15 elements. Okay, because here we have 3, here we have 5. So 3 5s are 15 elements we will have. But the relation here defined is x comma y, where x is the first letter of the name y. If that is the case, then what are all the possibilities? A comma Abhi is possible because A is the first letter of Abhi. So that is the first element. Then B comma Banu is possible because the first letter of Banu is B. B comma Binay is also possible. C comma Chandra. The remaining things are not possible. So under this relation, only these 4 elements can be available, right? So this is called a relation. Relation is nothing but the subset of the cross product. Hope you people are recalling the concepts. And we have also seen how to express the relation using arrow diagram. This is called the arrow diagram. We will draw 2 ovals and this is A and this is B. The set A we will write all the elements and set B we will write all the elements of set B. We will write all the elements of set B and then we will map it. A to Abhi, B to Banu, B to Binay, C to Chandra. And Durai doesn't have any pre-image. We will call the elements in B as image and hence elements in A is called pre-image. Right? And this set A is called domain and this set B is called codomain. Then what is meant by range? Range means the answers what we got, that is called range. This we will learn in detail in the next concept, function. Based on function we have done. Hope you remember all these things. What is the difference between a range and codomain? Codomain involves all the elements of the second set, whereas range is the only answers what we got under this relation, under this function. What are all the answers we got, that alone will come under range. So under this relation we have Abhi, Banu, Binay and Chandra. So only these 4 will come under range. But under codomain all the elements of the set B will be there. Right? It has another name, image and pre-image. Right? Domain is the first element of the ordered pair. Codomain is the whole set of B. Range or image is the second element under the relation. Okay, range is a subset of codomain. Yes, these are all the things we have learnt under relation. Next, how many relations a 2Z can have? Number of possible subsets of A cross B. How many subsets we can derive out of the Cartesian product A cross B? That many relations we can derive. So how many subsets are there for a set? If n of A is P, n of B is Q, then n of A cross B is PQ. We know how many subsets will be there. If a set has n elements, then there will be 2 power n subsets. We have learnt under sets chapter, right? So if a set has n elements, then any set can have 2 power n subsets. So now we are talking about A cross B. A cross B has PQ elements. So how many subsets A cross B can have? 2 power PQ. So that many relations we can define for 2 sets. Yes. So under second exercise we have solved problems based on this domain range. So again I am repeating, range is the answers what we are going to obtain out of this relation. Okay, that is called range. So they may define you some relation and they asked you to find the domain and the range. So first you have to find the elements under this relation. For example, if you take this x comma y, where y is equal to x plus 5, x is less than 4, x comma y belongs to n. So how will you get the answers for this? X is less than 4. So what are all the options for x, where x is a natural number? Natural number starts from 1. So x can take up the value 1, 2, 3. Right? Then what is y? If x is 1, y is going to be 6. So 1 comma 6. If x is 2, y is going to be 7. If x is 3, y is going to be 8. So these are the 3 elements under the relation R. So the domain is 1, 2, 3. Range is 6, 7, 8. Right? Like this only you have to find out the domain and the range of the function. Hope you recalled all these things. Hope you got a clear idea about what is domain, range and the codomain. Codomain means the entire second set. Range is a subset of codomain. The answers which you obtain under the relation, right? Next concept what we have learnt under this chapter is functions. It's a very important concept. What is meant by function? A relation is called a function if every element of set A has one and only one image in B. Remember, every set in A has one and only one image in B. If an element in A cannot have two images in B. If it has two images in B, then it is called not a function. Okay. If f is a function, then f from A to B, like this only we will denote a function. F is a function from set A to set B. Then the ordered pair belongs to the function f such that f of A equal to B. Okay. So under this function, an element in A will give you the answer as B. Then we will denote it in the ordered pair like A comma B. Here B is the image of A under F and A is called the pre-image of B. And by this time we are familiar with the words image, pre-image. Just now I explained all these things in relation, right? So what is meant by a function? Function is a special kind of relation. What is that special? In what way it is special? It has two constraints to be satisfied. What are those two constraints? A relation will become a function only under these two conditions. What are those two conditions? Every element in A should have only one image in B. And all the elements in A should have a image in B. None of the elements in A should be left free. If these two conditions are not satisfied, then it is not a function. Then when it will become a function, every element in A should have a image in B and it should not be left free, and every element in A should have one and only image in B. It should not have two images. Got it? So here is an example. This is also not a function, right? Because 9 has two images, 3 and minus 3. Right, here the function is defined as square root of x. 9 can have 3 or minus 3. 4 can have 2 or minus 2. Therefore, this is also not a function. If you see this example here, one element is left free without any image. Therefore, this is also not a function. So, I have given you a clue to remember. Your left palm is an example of not a function and your right palm is an example of a function. What is your left palm? If you take your left palm, it connects to 5 fingers. So this you should take it as a domain and this you should take it as a codomain. So an element in domain cannot have 5 images. If that is the case, it is not a function. But 5 elements in A can have a single element as image. Then it is a function. So I gave you a clue to remember. Hope you people are recalling all these things. Next is real valued function and real function. What is meant by real valued function? The range should be the set of real numbers or any subset of real numbers. Then it is called as real valued function. The real function means the domain itself is a real number system. Okay, then it is called a real function. Okay, then we have seen certain functions and their graph. First is identity function. Identity function means the element will map to itself. Domain will be equal to the range. If an element is mapped to itself, then we will get a straight line. 1 mapped to 1, 2 mapped to 2, like that. Then we will get a straight line passing through the origin. Then we have seen constant function. Constant function means an element will, all the element in the domain will map to a single element in the range. These are all not important from the point of problems or exercise. These questions may be asked in your 1 mark. What will be the graph of a constant function, or identify the constant function from the below given options. Like that you may get questions, right? So you have to be aware of the definition of the function. Constant function means all the elements in the domain will map to a single element like this. Then polynomial function, we know, right? The element will map to a polynomial. And how the graph of this, if it is going to be quadratic, it will be a parabola, open upward or downward, rightward or leftward. If it is going to be a cubic polynomial, we will get a curve. Likewise, it goes on. Then rational polynomial, a numerator is a polynomial, denominator is also another polynomial. That is called rational functions. Then is modulus function. We know what is meant by modulus. If x is greater than or equal to 0, it will be a positive number. If x is less than 0, it will be a negative number. So the graph will be like this. Right? Greater than or equal to 0, positive number. Less than 0, it is a negative number under modulus function. Then your graph will be like this. Here the domain is the real number. Range is the closed at 0 and open at infinity, because it is going to be modulus x. Modulus means for all values we will take it as a positive number, right? Next is called a signum function. Signum function is a special case of modulus function. Here we will restrict to 1. If x is greater than 0, then it will map to 1. If x is less than 0, it will map to -1. If x is 0, it will map to 0. So this is a special case of modulus function. So your graph will be like this. If it is greater than 0 here, less than 0 like this, and if it is 0, we will get here, right? Next we have seen a greatest integer function. Greatest integer function is, we will take the greatest value of the greatest integer less than or equal to x. So if it is equal to -1, for -1 less than or equal to x less than 0, and it is equal to 0, for 0 less than or equal to x less than 1. We will denote it inside the square brackets. See, the greatest integer of -2.3 is going to be -2, which means we will take the greatest integer less than or equal to x. This is our x. We will take the greatest integer less than this x. So less than -2.3 is going to be -2. Got it? So this is greatest integer function. Then we have seen algebra of real functions, like addition of two real functions. What will happen? F plus g of x is nothing but f of x plus g of x. The sum of two functions and for a particular value is same as adding their images under those respective functions. F plus g of x is nothing but f of x plus g of x for all x belongs to x. The same way subtraction is also holds good. F minus g of x is f of x minus g of x. Multiplication is of a scalar. Alpha into f of x is nothing but alpha into f of x. Then multiplication of two real functions. Fg of x is f of x into g of x. Then it is true for quotient of two real functions as well. Then we have seen an important concept. This is very, very important, where you will get definitely a question out of this. Find the domain and the range of a real functions. How to find the domain and the range? First question, if you see f of x equal to minus modulus of x. First you have to analyze what the function is defined, how, in what way the function is defined and where it is defined. You have to analyze it properly, then only you can give the domain and the range. We know that modulus of x is x if x greater than or equal to 0, minus x if x is less than 0. But here the function is minus modulus x. So minus modulus of x is minus x. This will become minus, right? We are multiplying it by minus. So this has become minus x if x is greater than or equal to 0. And this minus x will become plus x if x is less than 0. So it is very clear the domain of f is the entire real function. This is true for the all real numbers, right? For x greater than or equal to 0 also it is defined, x less than 0 also it is defined, right? Therefore the domain of f is entire real number. How to find the range now? If you check out the range, now range of f of x is minus modulus of x. Right, this is all real numbers except positive real numbers. Why except positive real numbers? You will get all real numbers. See, if x is less than 0, the answer is x. If x is less than 0, it is going to be a negative number. If it is going to be a negative number, we are getting the same number as our answer. So it is going to be a negative number. If x is greater than or equal to 0, which means if x is a positive number, under this function you will be expressing it as a negative number. So if it is going to be a negative number also, the answer is negative number. If it is going to be a positive number also, the answer is going to be a negative number. So under this function, all the answers are going to be negative, and there is possibility of getting 0 also. If x is equal to 0, we are going to get 0. So the range is minus infinity comma 0, where it is closed under 0 and open at minus infinity, because 0 is included there. Alright, this how only you have to analyze a problem, and then you have to give the domain and the range. Right, now let us see one more example. Square root of 9 minus x square. Here f of x is defined for all real numbers, that is x is greater than or equal to minus 3 and less than or equal to minus 3. Right, so the domain of f of x is the set of all x such that minus 3 less than or equal to x less than or equal to 3. Why this is not defined for a number out of this range? Because your square root of 9 minus x square. So x square can have a number less than or equal to 9. If it is going to be greater than 9, we will get a negative number. Negative of a square root is not a real number, and we are restricted to real valued functions only under this chapter. Right? So we should conceive the number which should be less than or equal to 9. When we will get less than or equal to 9? When x takes up the value less than or equal to 3. Right? If it is going to, because 3 square only 9, 4 square is going to be 16. It will be a number greater than 9. So even if it is going to be minus 3, on squaring it will become plus 9. So the domain is the closed interval minus 3 comma 3. Right? What will be the range now? You have to check out the answers for this. So when it takes the utmost value 9, the answer is going to be 0. Right? So the answer is 0. If it takes the least value as 0, then it is going to be 3. Because 9 minus 0 is 9, square root of 9 is 3. Right? So the range is the closed interval 0 comma 3. So the answers, all the answers lies in between 0 comma 3. Like this only you have to analyze and give your answer. Hope you people are recalling what we have learnt under this chapter. There is another type of problem. Find the range means always start from the constraint which is given to you and try to find out what is this f of x. See here, f of x equal to 2 minus 3x. X belongs to R and x is greater than 0. So start from here. X is greater than 0. So try to obtain this f of x. If x is greater than 0, 3x will also be greater than 0. What will happen to minus 3x? It will become less than 0. Why it is minus? Because it is there in the question. Then 2 minus 3x is less than 2. Why? Because we are adding 2 on both sides. Now we got f of x. So f of x is less than 2. Alright. So f of x is less than 2 means the range is going to be minus infinity to 2. Less than 2. Less than 2 means this side. Right. So minus infinity 2. This is how only you have to find the range. Right. So for the next problem, if you see x is a real number. Real number means x is a if x is a real number, from there we have to start to obtain our f of x. In f of x we have x square. If x is a real number, x square is going to be always a positive number. While squaring it will become positive. So x square is greater than or equal to 0. So x square plus 2 will be greater than or equal to 2. So f of x is greater than or equal to 2. And hence the range is going to be 2 to infinity. Since we have equal to here, we marked it as closed interval. In this problem it's just less than. So we marked it as a open interval, right? Next, let us see an example of a rational function. So how to find the domain? Domain, how we will give you an answer? You have to analyze where the function is not defined. So omitting that value, the entire real number system will come under the domain. In that way, you have to analyze a question. Okay, so here how to find the domain of f of x? We have to check out the function. Here the denominator should not be equal to 0. right? So the function is not defined when the denominator is equal to 0. So if you take equal to 0, after factorizing, we got the x values as 6 and 2. So under 6 and 2 alone, the function is not defined. Otherwise, the function is defined and the entire real number system. So the domain is going to be real number minus 2, 6. Okay. So we have seen few models how to find the domain. First, if you have a simple questions like this, you can analyze the function and you can give the answers directly. When it is square root, remember square root answer should be positive. In such a way, you have to choose your x values, right? When it is going to be a rational function like this, the denominator should not be equal to 0. So you find when the denominator will become 0 and that element, that values alone can be omitted from the real number system, then the entire remaining will form a domain. So r minus that value, right? So we have seen there is another example to find the domain and the range. Square root of x minus 1. Then again, as I told you, to find the domain, it should be a positive number. So what value, for what value of x this will become positive? Here x should be greater than or equal to 1. If it is less than 1, it will become negative, right? So the domain is greater than or equal to 1. So 1 comma infinity, closed at 1 and open at infinity. How will you find the range now? As I told you, you have to start from the constraint which is given and try to arrive at the function. Here x is greater than or equal to 1. Now our function is x minus 1. So x minus 1 will be greater than or equal to 1 minus 1, which is 0. Therefore square root is also greater than or equal to 0. And hence f of x is greater than or equal to 0. Therefore closed at 0, open at infinity. So in this way you can solve a problem if you get a question inside the square root. Now there is another example how to find the range of a function, rational function. Third question. So here we can take y is equal to the function, which means f of x equal to the function. We need to know what is our y, right? So you can cross multiply it, yx minus 2y equal to x minus 1. So bring all the x to the other side. So x is equal to 2y minus 1 divided by y minus 1. Our denominator should not be equal to 0. So y minus 1 should not be equal to 0, which implies y should not be equal to 1. So 1 alone should be removed from the range, real number. Therefore r minus singleton 1 will be the range. So when you have a rational function like this, how to find your range? Take this function as your y and cross multiply it. Check out for your x. Right, in terms of x, then you see y, the denominator should not be equal to 0. What will be the domain for this function? For the domain, the denominator should not be equal to 0. So x minus 2 should not be equal to 0. So x should not be equal to 2. So except for 2, for all other real number, the function is defined. So the domain for this function is r minus singleton 2. Hope you got it. So to find the range, what you should do, you have to check out where the functional value should not be equal to 0. So rewrite it in terms of y and check out where y is not equal to 0. Right? So this is the way to find the domain and the range for a rational function. And this is the way to find the range and the domain for a function which is under square root. And if you get a simple polynomial like this, 2x plus 3, you know how to find it. We have seen examples like this, right? Directly you can find, you can start from the constraint and you can arrive at the function. You can tell where, what your range are you arriving at, right? So these are the various concepts we have learnt under this chapter. I want you to do all these questions as homework so that you will get a clear idea about the concepts what we have learnt under relations, right? So with this, let us wind up today's class, and if you have doubts you can ask me. Thank you, students.